Module 2, Lesson 1, Interpreting Division of a Fraction by Whole Number Visual Models. All right, taking a look at some I-CAN statements. For our particular team, we did not decide that dividing fractions was an essential learning target, so we don't have learning targets in this particular section, but we do have I-CAN statements. I can use visual models such as fraction bars, number lines, and area models to show the quotient of whole numbers and fractions and to show the connection between them and the multiplication of fractions. So we are looking at a connection between division, quotients, and multiplication. We want to connect these two things together. And we also want an end result here that we can divide a fraction by a whole number. And we do want to represent this visually so that we can see what's actually happening. So in class, you would have a partner activity. You and your partner would each work a set of problems. One of you would be invited to solve these problems using, well, you would write division sentences. The other partner would write multiplication sentences. So I'll take a look here at each of these exercises. There are 3 of them. So looking at A, partner A, writing a division sentence to solve each problem. 8 gallons of batter are poured equally into 4 bowls. How many gallons of batter are in each bowl? So I hear that I'm taking the 8 gallons, and I am dividing it between 4 bowls. So the 8 gallons per 4 bowls, connecting this to the Module 1 work where we worked on rates, and we could then work with just the 8 to 4, and we have 8 divided by 4, which would give us 2 gallons per bowl, and we have a very nice unit rate there. And I could represent this using a tape diagram. And I've got 1, 2, 3, 4, 5, 6, 7. So I have 8 gallons, and I need to put them into groups of 4 bowls. So I could put something in the first bowl, second bowl, third bowl, fourth bowl, and then I can go back to the first bowl, second bowl, third bowl, and the fourth bowl, and I find that each bowl is going to receive 2 of the gallons. So I've got 2 in the first bowl, 2 in the second bowl, 2 in the third bowl, and 2 in the fourth bowl. Taking a look at partner B, write a multiplication sentence to solve each problem. 1/4 of an 8-gallon pail is poured out. How many gallons are poured out? So I've got a big 8-gallon pail, and I'm going to pour out 1/4 of it. I'm going to dump it on the ground, or I'm going to put it in another container. And the question is, how much of it did I pour out? Now, if I read carefully here, I notice there is a multiplication expression here, which is good because I'm supposed to use multiplication. So I've got 1/4 of 8 gallons. 1/4 of 8 gallons. Well, in my head, I'm thinking, okay, I've got 8 gallons. 1, 2, 3, 4, 5, 6, 7, 8. And I want 1/4 of it. So group of 2, a group of 2, a group of 2, and a group of 2. 1/4 of the 8 gallons is going to be 2 gallons. Now, it's right about here that my brain is starting to think, hey, doesn't that look an awful lot like the diagram, the illustration that I did over here? Which is kind of puzzling to me because this was a division problem, 8 divided by 4, and this is a multiplication problem, 1/4 times 8. So I'm a little confused about seeing the same illustration for a division problem and a multiplication problem. My brain is going to struggle with this. But I know that my models are good, so I'm going to let it go here. And I see that on both of these problems I got an answer of 2. So I'm going to let that ride there, and I'm going to let my brain think about it for a little bit. In the meantime, I'm going to move on to the second exercise here, a division sentence to solve the problem. 1 gallon of batter is poured equally into 4 bowls. So I've got 1 gallon, and I want to split it amongst 4 bowls, and that's no big deal. I've got a gallon here, and I'll split it into 4 parts, and this is how much is going to go in each of the bowls. So that is 1/4 of a gallon. And of course, I could connect this to my rates. I've got 1 gallon per 4 bowls, and right here I have my unit rate, 1/4 per bowl, 1/4 gallon per bowls, per 1 bowl. All right, so now I'll take a look over here at this multiplication side. 1/4 of a 1 gallon pail is poured out. How many gallons are poured out? So I've got a 1 gallon pail again, and I'm going to move 1/4 of it out, so I'll need to make fourths here. And 1/4 of it is going to be poured out, so that's 1/4. Now I'm supposed to be writing a multiplication sentence, and I see right here 1/4 of 1 gallon. 1/4 of 1 gallon. And I see that that is a fourth. Now, this is the second time in a row this has happened, but my models look the same. And I'm starting to be a little concerned about that. I'm starting to wonder if I'm doing these wrong, or is there something else going on here that I don't understand. So I'm going to take a quick look here and just double check my work here. 1 gallon. And I want to put it equally into 4 bowls, so I'm taking 1, and I'm going to divide it into 4 parts, and this is equal to 1, and I've made 4 parts, and this is how much goes in the bowl. Well, that's 1/4. I'll come over here and look at my multiplication here. 1/4 of 1 gallon. Okay, so I need 1/4. So here's my gallon, and I've made 4 parts because it says 1/4, and there's my 1/4. So I'm starting to wonder now if there's a connection between these things that are going on here. Is there something more profound or bigger or deeper that I just don't understand yet? So I'm going to keep this in the back of my mind. I'm going to take a look at the next example, and I'm going to start asking myself, are there some connections here? So it says here we're going to write a division sentence and draw a model to solve, and I've already been drawing the models so that we can follow my thinking as I've gone along here. 3 gallons are poured equally into 4 bowls. So I have 3 gallons per 4 bowls, which means 3 divided by 4 gallons per bowls, and 3 divided by 4 is 3/4 gallons per bowl. Once again, connecting to that unit rate stuff that we just completed in Module 1. For a model, I'll erase here. I'm going to have 3/4 gallons per bowls. And I need to have a model here, so I've got 3 gallons. And it says that I need to take my 3 gallons, and I need to split it equally among 4 bowls. Well, I don't see how 3 is going to split up very nicely into 4 bowls. So what I'm going to do here is I'm actually going to create each of my gallons. So I've got my first gallon, my second gallon, and my third gallon. And what I'm going to do, I think, is I am actually going to divide each of these pieces into 4 parts. Because then I can say, this is how much I want to put in the first bowl, and this is how much I want to put in the second bowl, and I want to put this in the third bowl, and I want to put this in the fourth bowl. So you can see how I took each of my gallons and said, I'm going to split them into 4 parts, and then I can divide each of those 4 parts into their bowl. I can move them into their bowl. So each bowl is going to get 3 parts. And each of those parts is 1/4 of a gallon. So I get 3/4 of a gallon per bowl. Now if I step over here to the multiplication side, it says 1/4 of a 3-gallon pail. 1/4 of a 3-gallon pail. Now multiplying fractions, most students love those, because all you have to do is multiply straight across. Now I'm a big fan of, while you're learning, make sure you put your denominator in for your whole number. All whole numbers have a denominator of 1. So when we see 3 there, we know it has a denominator of 1. And then I can multiply straight across. 1 times 3 is 3, and 4 times 1 is 4. And I find out I've got 3/4 gallons per bowls. Now it says 1/4 of a 3-gallon pail is poured out. So I'm back to this 3-gallon pail again. And so there's my 3 gallons, 1, 1, and 1. And I need to pull out 1/4 of it. 1/4 of my 3-gallon pail. And once again, taking 3 and splitting it into 4 parts isn't very easy, but I know that I can take each of these and divide them into fourths, and I can get rid of 1/4 of each of them. I can pour that out. So here's a 4th, and here's a 4th, and here's a 4th, and that's 3/4 of a gallon. And once again, my models really look similar. So now I'm starting to think, okay, there's something going on here. There is some kind of connection. And yes, there is a connection, and that is something that we want you to learn in this lesson, that there is a connection between multiplying and dividing. In this case, dividing by 4 has the same effect as multiplying by 1/4. These two expressions, if you want to call them that, mean the same thing. We have the same result. Taking a number and dividing it by 4 is the same as multiplying it by 1/4. On all of these examples, we had the same whole. In this example in particular, we had the same whole, 3 gallons. One time we divided it by 4, the other time we found 1/4. Divided by 4, found 1/4. The result was we had the same answer both times, 3/4. So dividing by 4 is the same thing as multiplying by 1/4. And as we saw in the other examples, it works with a variety of numbers. It's not something that is magical about a 4. Dividing by 5 is the same as multiplying by 1/5. Or as we saw in exercise A, sorry, not exercise A, as we're going to see as we go through some examples. We're not to exercise or example A yet. We're going to see that this isn't something that is unique to just the number 4. All right. So before we go any farther, I want to introduce a division vocabulary word, and this is partitive division. The examples that we're looking at today as we go forward are examples of partitive division. And partitive division answers the question, how much or how many in each group? So we are given a total, and we are told to put them in a certain number of groups, and we are answering the question, how many would we put in each group? For example, we are given 24 cookies, and we are going to put them in 6 groups. And the question is, how many will be on each plate? How many will we have in each part? 6 is the divisor. It represents our number of groups. 4 is our quotient, and it represents how many cookies we would have on each plate. There's another kind of division that we'll talk about. It doesn't come up in this lesson, but I'd like you to start remembering that partitive division answers the question, how much or how many in each group? And the examples that we look at today are examples of partitive division. All right, so example 1. 3/4 of a gallon of batter is poured equally into 2 bowls. How many gallons of batter are in each bowl? So once again, we're given a total, and we are going to put it into some groups, and we are answering the question, how much is in each part, which is partitive division. And if I were to draw a model of this, I've got 3/4, and I need to take this 3/4 right here, and I need to take this 3/4 and I need to put it into 2 equal sized groups. And the question is, how can I do that? Well, one of my favorite things, and you'll notice I use tape diagrams a lot for this, is I'm going to take this and I'm just going to divide it by 2. I have taken everything on here and I've said, all right, I'm going to divide it in half. And the question then is, where is this half of the 3/4? I divide it in half because dividing by 2 is giving me a half. And I know that I am looking at this piece right here. So the 3/4 is all of this, and I have split it into 2 equal sized pieces, here and here. And the question is, how much is this? Well, in the whole, 1, 2, 3, 4, I can see that there are 8 parts, and I can see that these pieces right here, I have 3 of them. So I can figure out that 3/4 divided by 2 is equal to 3/8. So I have the 3/4, I have divided it by 2, and I have figured out using a model that I have 3/8. Now this is using a bar model. We can also do this on a number line. I've got 0, I've got 1, I need to make my fourths. So I've got 1/4, 2/4, and 3/4. And I want half of this 3/4. So what I'm going to do here is say, okay, if I want half of the 3/4, I'm going to have to add some more lines here, because I know that 1/4 doubled is going to give me 2/4. And if I double 2/4, I'm going to get 1. So I know that I need some other lines in here. And what I'm going to do is take everything and I'm going to split it into 2, because I am putting it into 2 bowls. And it's important to notice that I go the entire distance from 0 all the way to 1 as I do this division. So now my distance from 0 to 1 has been split into 8 pieces, and I can see that this 3/4 here is equal to 1, 2, 3, 4, 5, 6 of those eighths. And I can see that half of the 6/8 is 3/8. Right here is my halfway point. So I can see that 3/4 divided by 2 is 3/8. Now, I was noticing in the exercises that there was a connection between our division number sentences and our multiplication number sentences, 3/4 divided by 2. Can I write a multiplication sentence to answer this question? Well, I've already said that dividing by 2 is the same as finding half. I just said that. It just came out of my mouth. And a half is a fraction. And I'm looking for half of something else. Half of 3/4. I'm taking the 3/4 and dividing it by 2, which means I am finding half of 3/4. And if I multiply, 1 times 3 is 3, and 2 times 4 is 8, and there is my 3/8. So I have just proven that 3/4 divided by 2 is 3/8, and that 1/2 times 3/4 is also 3/8. So all of this stuff is equal to each other. All right, looking at example 2 here. 3/4 of a pan of lasagna is shared equally by 6 friends. So in my head, I've got this picture of 3/4 of a pan of lasagna. So here is my whole pan of lasagna, and there is 3/4 of it, and it is going to need to be split by 6 friends. Each one of them is going to want a piece of the lasagna. So I'm going to need to make 6 pieces out of this. Now it's interesting, as I was looking at this, I noticed that I've got 3 pieces here. And if I were to cut these again, I would then have 6 pieces. So a piece for a friend, 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 and a piece for a friend. So I have taken my 3/4 and I have divided it into 6 pieces. I have made 6 groups out of this, and the question is, how much is each of my friends going to get? How much is each of these pieces worth? Well, there are 8 total pieces in the lasagna now. If I look carefully, I see 8 total pieces. And each friend is going to get 1 of those 8 pieces. Each friend is going to get 1/8 of the 3/4 pan of lasagna. Now, looking at my picture here, I can see that each of these is 1/6 of the 3/4. Each friend is going to get 1/6 of the lasagna. And if I set this up to multiply, 1/6 times 3/4 gives me 3/24, which if I simplify it, writing it in the largest possible units, I will find that each friend is going to get 1/8 of the pan of lasagna. Once again, 1/6 multiplying by 1/6 is connected to dividing by 6. All right, let's take a look at example 3. So a rope of length 2/5 of a meter. So I've got 2/5 of a meter, and I am going to cut it into 4 equal size pieces. So I'm going to take 2/5, and I'm going to divide it by 4. So I can draw my tape diagram here, and fifths, 1, 2, 3, 4, and I've got 2 of them, and I need to divide these into 4 pieces. Well, I really love using vertical lines and horizontal lines. It really keeps my work easy for me to look at. So the 2/5, which is right here, has been divided into 4 parts. And so here's a part, And here's a part, and I know my picture isn't very good at equal-sized parts, but they're supposed to be equal-sized. And I have made 4 parts, and I am looking here, and I am noticing that each of these has 2 parts in it, and there are a total number of parts, 1, 2, 3, 4, 1, 2, 3, 4, 5. There are 20 total parts. So there is 2/20ths of the meter in each of my little 4 parts here. And if I were to rewrite this in the largest possible units, I would find out that each one of them is 1/10 of a meter. Now, of course, the question is, could I turn this into a multiplication sentence? When I say that I'm going to cut it into 4 equal parts, that means that I want 1/4. I want 1/4 of the 2/5 meters. And so I've got 1/4 times 2/5, which gives me 2/20ths, which if I rewrite it in the largest possible units, if I simplify it down, gives me 1/10 of a meter. So once again, this connection between dividing by 4, multiplying by 1/4. Here we divided by 4, here we multiplied by 1/4. Divide by 5 is the same as multiplying by 1/5. We have a strong connection between this multiplication and this division. All right, taking a look at some exercises here. We are going to fill in the blanks to complete the equation, and then we're going to find the quotient and draw a model to support our solution. So I have 1/2 divided by 3, so I have my division number sentence here, and I need to figure out what this would look like as a multiplication sentence. Well, I can see here that we're dividing by 3, and I know that if I divide by 3, that is the same as multiplying by 1/3. And if I were to draw a model here, I've got 1/2, and I want to divide it into 3 pieces. And then I can find that each one of these pieces is 1/6. And then I've also got over here, interpreting this, the multiplication sentence, 1/3 of 1/2. So I've got 1/2, which is right here, and I want to cut it into thirds, and 1/3 of 1/2 is 1/6. And I hope that you can see that the models that I drew were identical. They were the same thing. Dividing by 3 is the same as multiplying times 1/3. All right, exercise 2. Here I am dividing by 4, and that is the same as multiplying by 1/4. So that would mean that this right here should be a 3. Because here I'm taking 1/3 and dividing it by 4, and here I am looking for 1/4 of 1/3. So let's see, 1/4 of 1/3. So I need thirds, and I want 1/4 of my thirds. So I'm going to cut horizontally now. And so here is my 1/3, and here is my 1/4. 1/4 of 1/3. And I've got one piece there, and I've got 12 total pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 1/12. 1/4 of 1/3 is 1/12. And if I were to say take 1/3 and divide it by 4, I have the same results. The picture would look the same. Here is a third, divided into 4 pieces, and here is 1/4. It is 1/12. All right, exercise 3. 1/4 divided by 5. So I need a fourth, and I want to split it into 5 pieces. And I'm going to try this one on a number line. I'm not as comfortable with this, but I'm going to be brave. So I've got 0 here, and I've got 1 over here, and here is my 2/4, and here is my 1/4, and here is my 3/4, and I want to take my 1/4 and I want to cut it into 5 pieces, which means I'll have to cut it 4 times. 1, 2, 3, 4. Now, if I want to count up how much of 1 this is, I have to divide all the rest of them too, because I want to know how much this 1/4 divided by 5, this little piece here, I want to know how much of 1 that is. So I need to go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and I can see that I've got 5 pieces, 5 pieces, 5 pieces, 5 pieces. I've got a total of 20 pieces here, and I can see that one of these pieces is my divided by 5, so 1/20. So using a number line works just as well as a tape diagram, although we may not feel as comfortable with it. I don't, but that doesn't mean you won't. I can also do my tape diagram that I love. I've got 1/4, and I'm going to cut it into 5 pieces. 1, 2, 3, 4 cuts to make 5 pieces. So here is my 1/4, and I have divided into 5. So here's a piece, and here is 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 a piece. So I've got 1 piece here out of 20 pieces, and it's 1/20 again. So dividing by 5, multiplying by 1/5, same thing. I could have just as easily done 1/4 times 1/5. Although I would prefer to write it the other way, 1/5 of 1/4, and I would get 1/20. All right, exercise 4. 3/5 divided by 5. So I have 3/5, and I want to put it into groups of 5. Making sure that I've got the right problem written down here, because yeah, I'm pretty sure that in my materials it shows this as 3/4 divided by 5. In the student materials it might have something that looks a little bit different here. Let me double check real fast. Pull out the old workbook here. Go to Module 2. Lesson 1. And we are looking at, all right, in the student materials it has 3/5 divided by 5. So I'm going to do this problem instead of the one that's in the teacher materials. So I've got 3/5. 1, 2, 3, 4 cuts to make fifths, and I've got 3 of them. So here is the 3/5, and I need to split it into 5 pieces. 1, 2, 3, 4 cuts to make 5 pieces, and I am looking at how much is in each of the groups, partitive division, how much would go in each part, and I can see that I've got 3 pieces in there. And I know that I've got 5 this way, and I've got 5 this way, so there are 25 pieces there. So I have 3/25. I could also say that I'm looking for 1/5 of 3/5, which would give me 3/25. And the model would look the same. 1/5 of the 3/5. All right, exercise 5, 1/5 divided by 4. So I've got 1/5 here, and I want to put it into 4 parts. Of course, my brain's screaming at me, hey, couldn't I just do 1/4 of 1/5? So couldn't I take 1/5 right here? And it's 4 cuts, 1, 2, 3, 4. So now I've got my 1/5 right here. And I'm looking for 1/4 of that. So I can do my horizontal cuts here. And I am looking for 1/4 of the 1/5. So here's 1/4 of the 1/5. And that is going to be 1 piece. And I know that there are 5 this way and 4 this way, so there are a total of 20. So 1/4 of 1/5 is 1/20th. Or I can look and say I took 1/5 and I divided it into 4 pieces and I got 1/20th. These two things right here are the same. All right, exercise 6. Solve, draw a model to support your solution. So 3/5 pint of juice is poured equally into 6 glasses. So I've got 3/5 pints of juice per 6 glasses. So I'm going to go and connect that back to my rate problems for Module 1. And I'd like to scale this down to 1 glass. So I'm going to scale down to be 1 glass, which means I'll divide by 6. So I'll take 3/5 and I will divide it by 6. So I want 3/5 divided by 6. And so I need to have my model here. 1, 2, 3, 4. And I've got 3/5. And I need to make 6 pieces out of that. So I'll make some horizontal cuts. I'll need to cut 5 times to make 6 pieces. 1, 2, 3, 4, 5. And I'm asking how many would be in each of these groups. I made 6 groups, partitive division, how many in each group. And I know that I've got 3 pieces in each group. And the question is, how big are those pieces? And I know that I've got 5 going across, 1, 2, 3, 4, 5. I've got 6 going down, 1, 2, 3, 4, 5, 6. So there are 30 pieces. So I have 3/30ths per 1 glass. And if I were to rewrite this in the largest possible units, I would have 1/10 of a pint per glass. And of course, I could also turn this into a multiplication problem. And I could say that I am looking for 1/6 of 3/5, which would give me 3/30ths, which would simplify to be 1/10. All right, so what is the relationship between dividing by 4 and multiplying by 4? The relationship is they are the same thing. It's the same thing. When we divide by 4, it is the same as multiplying by 4. And what's really important from this lesson is that you can show this with models. It's not that you have memorized this relationship. It is that you can show this relationship and explain this relationship using models. So I can statements here. I can use visual models such as fraction bars. We'll use fraction tiles here in class. Number lines I demonstrated. And area models, which look like the tape diagrams, to show the quotient of whole numbers and fractions and to show the connection between them and the multiplication of fractions. So we were doing division with whole number and fractions, and we connected that to just multiplying fractions. So 3/4 divided by 4 being the same as 1/4 times 3/4. So here we have division with a fraction and a whole number. And here we have multiplication with fractions, and we are saying that they are equal. And feeling very comfortable with dividing a fraction by a whole number. So this concludes Module 2, Lesson 1. If you've got any questions, make sure you talk to your teacher. And make sure you complete your problem set.